Okay, so let's continue with our example. So example was ZL was 200 minus J 100 ohm. Z naught was excuse me. Okay, so Z naught was 100 ohm. Frequency was given to us 500 megahertz, and our goal was to design L network. So in our solution, we have completed the first step, and the first step was selection of L network. So after using the mentioned method, what we found is that this is the network that is going to solve our problem. So X and this circuit was uh, given a name of L network number 1. Okay? But as I mentioned, this is not some kind of a universal name. You can call it L network number A, L network number B, or L network number X. Okay, there is no such there is no such rule that you will always call it L network number 1. I'm using this notation. I have devised this notation on my own. Okay. Now, the second task is to find out what is X and B. Okay. So possibilities are there can be inductor or there can be capacitor. Similarly, whether this B is inductor or whether this B is capacitor. So this is something that we will find in the next step with the help of Smith chart. So once we know the B and X value, then it will be easier for us to make this conclusion whether there is a capacitor or there is inductor over here. So let me move to the Smith chart. So the normalized load impedance हम find कर चुके थे जी क्या आई थी हमारे पास. So ZL normalized load was 2 minus J. And we have already located this on the Smith chart. So let me so this is the Smith chart, and we located our values over here. So it was at this point. Let me change red color. Okay. So this is ZF. Now the question is how we will proceed further. Okay. Now, whenever you are solving any problem related to L network, you need to draw a circle that I will call as, so I will say draw 180-degree rotated 1 plus jx circle. So the chart that you are looking at, this chart is, if you remember, there are two types of Smith chart. One is impedance Smith chart and other is admittance Smith chart. The chart that you right now looking at is admittance impedance Smith chart. Impedance Smith chart. And why I'm calling it impedance Smith chart, because on this chart you can see that there are resistive circles and there are reactive circles. Okay. Now the circuit that I was that we need to design is, what is the, let me draw that circuit over here as well. So the circuit that we need to use is, it consists of one element in series and other element in parallel or shunt configuration. So this is the L network that we are going to solve. And in this circuit, there are two elements, X and B. This is the series element, and this one is shunt. So as an electrical engineer, whenever you are solving a circuit in which elements are connected in series, so normally you operate in the impedance mode. You solve your problem in terms of impedances. But if your elements are connected in shunt or parallel configuration like this one, then it will simplify our analysis if we operate in admittance mode. Okay, so what I'm saying is, where for series configuration we use impedance, and for shunt we use admittance. Because L network consists of both series and shunt, so it means we have to operate in the impedance mode as well as admittance mode. But the chart that I'm using, it is only impedance Smith chart. Okay, and you already know from before midterm we explained this concept, that because of the 180-degree relationship between impedance and admittance, the same chart can be used either as impedance Smith chart or admittance Smith chart. Because if you rotate this chart by 180-degree, the resistive circles becomes conductance circles and reactive circles become susceptive circles. Okay. So based on this concept, whenever you are solving L network problem and you only have impedance Smith chart, so this 1 plus jx circle is already drawn in front of you. Okay, so what I'm going to do is, I'm going to uh, annotate this circle so that you understand the whole idea. So this is the circle that I'm talking about, which is drawn already. So make sure that you don't assume that you have to draw the circle. I'm just marking it so that you understand which circle I'm talking about. This circle is already there. So this is the circle that we call as 1 plus jx circle, which I mentioned before as well. So this circle is already there, okay? But what we are going to do is, we are going to draw a 180-degree rotated version of this circle. 180-degree rotated version of the circle. So of course you must have a compass and scale with you when you are solving such type of problems. I am just drawing them rough, but you will be able to understand the idea. So what I mentioned that you need to draw a 180-degree rotated 1 plus jx circle. So this is 1 plus jx circle, which is already there on the impedance Smith chart or the chart that you will be using in your exam. And now you are going to draw a 180-degree rotated version of the circle. So when you rotate this by 180 degree, when you rotate this circle by 180 degrees, so this circle will come over here. Okay. So I'm going to draw a rough uh, circle. So how you are going to do that? What you need to do is, you need to look at this horizontal line. So again, I'm just drawing it for your convenience. You don't need to draw it. What you need to do is, you need to this is the horizontal line. So you need to measure this line, okay, and find out the center of this. So let's assume if this is, let's assume it's a 10 centimeter. So at 5 centimeter, this will be there will be the center of this line. Okay, so you need to find out the center of this line somewhere over here. Let's say somewhere. And then with the help of a compass, you are going to draw a circle by opening the compass with up to this much radius. So this is going to be the radius of the circle that you will be drawing. Okay. So let me draw a circle again. As I mentioned, I'm going to draw it manually. So my circle will not be that much accurate, but with the help of a compass, you will be able to draw a very, you can say, accurate version of that circle. So let me draw a circle. So make sure that you have a compass and you do this with the help of compass. You should not be doing this in your exam. Some students, they assume that this is acceptable in exam. Okay. If you draw such type of circle, it means you are not serious in your exam. Okay. So this is the circle that you will draw, that I'm calling as 180-degree rotated 1 plus jx circle. Okay. Once you do that, then what will be the next step? So we have already located ZL. So like, okay, this is there. Now, how you are designing your circuit? So if you remember, there is a load connected at the output of this circuit. So this is our ZL. So we are right now at this point, and on Smith chart we are at this point. Okay. So what you need to do is you need to uh, you need to consider the circuit, and you need to consider the Smith chart as well. So with respect to circuit, when I am at the load position, so I am at this point, and with respect to Smith chart, this is the location of the. And now you can see that this element, the in the L network number one that we have selected for our problem, the element is connected in shunt configuration. Okay, and what I have plotted is impedance. But if you remember what I mentioned, whenever you are dealing with shunt configuration, you have to operate in the admittance mode. In other words, we have to transform this load impedance into the corresponding load admittance. And on Smith chart, you people already know how to transform impedance to admittance. Okay. If you don't remember, the idea was you need to draw a line connecting ZL to the center of the Smith chart. Okay. So what you need to do is you need to draw a line again, as I'm using it manually. So my line will not be that straight, but with the help of a scale, you must draw a straight line by first connecting this ZL to the center of this Smith chart somewhere over here. Okay. And then extend this line on the other side. So you need to make sure that you measure this distance. So if this is, let's say, 2 centimeter, then you need to extend this line up to 2 centimeter. So let's assume that you extend this line by this is so this is now. Let me stop over. What I have done is I have moved this point exactly 180-degree to its position on the other side. And now this point, because this was ZL, so now you will call this as YL. Because what we have done is we have converted the load impedance in terms of load admittance. Okay. So now once this is admittance and this is already admittance, okay, when you are representing these, which means this is admittance because Z is r plus jx, and y is g plus jb. Okay, so whether you are talking about y or whether you are talking about b, it means b means it is susceptance or the imaginary part of admittance. Okay. So right now we don't know what is b. So keep this thing in mind that we don't know what is the value of b. We are actually interested in finding the value of b and x. Okay, but this is what you will do. Okay, graphically, what you have done is you have transformed the load impedance into load admittance. Now, when you connect this b to this y, so of course this is the load imaginary value, and this is the value of b that you will connect. So we don't know what is the value of b, but we know that anything added to this, so let's say this is b1. So whenever you add anything to that, so that is only going to change the imaginary part of this. G will remain constant. Okay, so if you add b to yl, so now we are talking about yl, and because these two are connected in parallel, so in parallel configuration they are just added together. But the point is, this element, because this purely reactive element, it is only going to change the imaginary value. Okay, so we know from Smith chart perspective, whenever the real part uh, remain constant, but imaginary part changes, then you must be moving on the constant resistive circle. Okay, constant resistive circle. So it means if this is the point at which we stopped, so now when you add something to that, it is only going to move on this circle. You're only going to move on this circle. Okay. So what we want to do is the purpose of drawing this rotated circle was, now what we will do, we will find out if this point move to this circle. So one of the possibility is we can move in this direction. So I'm moving on this circle. I'm moving on this circle, and I will stop at the point at which I touch the 1 plus jx circle. You can clearly see that when I'm moving on this circle, so I'm actually moving on which circle? Resistive circle. And which circle? It's, if you again, the value may not be exact because I haven't drawn an exact circle, but roughly you can see that this is about zero point 0.4 resistive circle. Okay. So when I move on this circle, resistance is not changing, which means that this G is not changing. So what is actually changing? B must be changing. And how much B has changed? So what is the value of B? What is the original value of B of Smith chart? So if you look at it, it's I think close to zero point 0.2. Can you read it over here? 0.2. So when I move from this point to this point, so B has changed. So what you need to do is to find out how much B has changed. So again, as I am using a very rough calculation, so you need to find out what is this value. Okay, so if you draw the exact circle, so this value again, it's not exactly zero point 0.5, but it is 0.5. So from value of zero point 0.2, we have moved to the point where the value of B is 0.5. So what I'm saying is, let me write the equation so that it's clear to you. What I'm saying is that assuming y was equal to zero point 0.4 plus j point, which is this point. Okay, what is the value? What is the real part? Let's say zero point 0.4. What is the imaginary part of this point? 0.2. But when I move from this point to this point, so now at this point, what is the value? So let me call it, this was YL. Let me call it YL dash. So what is the new value of this point? It is 0.4 plus J 0.5. talking about this point, which I'm calling as YL dash. So how much the imaginary value has changed? It has changed from plus 0.2 to plus 0.5. Now, graphically, I was explaining this that I am actually moving. Okay, I am moving, but from circuit point of view, I can only move if I add something to this YL. And what I have added? I have added this circuit. I have added this element. So now I know that if this point, if it moves from this point to this point, how much should be B? How much should be B? B has to be equal to plus 0.3 because 0.2 has become 0.5. So how much I have added? I have added 0.3. So it means the element which I will connect over here, it has to provide this much susceptance. Then this point will move to this point. Using this method, we have found the value of B. And if you remember, if the value of B is positive, it's because it's a positive value. And we already know that if susceptance is positive, it means it is a capacitor. So at this point, we will connect a capacitor. Okay. So we also now know that this is a capacitor. Of course, we will find out the actual value of this capacitor, how much microfarad or how much picofarad, but at least we are sure that this element, it has to be capacitor. It cannot be inductor because the value of B has to be positive. Okay. Now, what is the next step that we are going to take? So now I have added the load effect to my to this element. So now we have solved this part. So now at this point, we are now at this point. From circuit point of view, I am at this point, right at this point. And what is the value of this? The value is, as I mentioned, it is 0.4 plus 0.5. So now we are having YL dash. But you can see the next element is now connected in series with it. And whenever we are in series, we have to now operate in the impedance mode. So this YL dash, first we need to convert it into impedance. Then we will be able to add the impedance to this series element. So again, what is the procedure? Same procedure. This is now YL dash, but I need to transform it into ZL dash. The procedure is same. How you will do that? You will connect this point to the center of the Smith chart, and measure this distance. And with the same much length, you need to extend it to the other side. You need to extend it to the other side. Somewhere. Again, this is rough again, but the idea is you need to understand the idea. What you need to do is draw a line from this point to the center. Okay. Measure this distance. Let's say this is 3 centimeter. Then extend this line further 3 centimeter. But you will observe that the point at which you will stop, this point will be exactly on the 1 plus jx circle that is already there on the impedance Smith chart. So you will be somewhere on this 1 plus jx circle. Okay. So now this is something that I call as Zn dash. And what you will observe is because this point is on the resistive circle of 1, so resistive part is 1, and because we are in the bottom half of the Smith chart, so the negative, the imaginary part must be negative, and you need to find out what is the reactive circle that it is passing through. Okay, so from this rough calculation, if you see, this is the circle that you need to identify, which is this circle. So again, from my figure, it is zero 0.4, let's say, but actual value is 0.1, 0.2 because I haven't drawn an exact circle. So what is this point? It is 1 minus j 1.4. So now we know that this is YL dash when it is transformed into ZL dash, we get 1 minus j 1.4. Okay. So what is the value of x now? If you remember, I mentioned this many times that from Smith chart perspective, if our circuit is matched, I have to be at the center. So my goal is to reach to this point. Right now, I am not at the center, I am at this point. But it's obvious that if I want to come to this point where I only have resistive part and that is equal to 1, so it means I have to cancel this part. I have to cancel this part. Right now, I am at 1 minus j 1.4, and I want to reach to this point where I have only 1. So it means minus j 1.4 has to be cancelled out. So now we know that this x, how much should be this x? This x has to be equal to plus j 1.4. Because it is already x, so I'm not writing j, but you know x means an imaginary part. So similarly, this is also b. B is an imaginary part, so I'm not writing j over here, but you know that this is j something. So plus 1.4. So when x is equal to plus 1.4, what will happen? This will cancel out, and graphically we will move to the center. So when we are at the center, our circuit is matched. So now, from Smith chart perspective, what has happened? You need to understand this point. We started with our load at this point. Our load was at this point. And because it was not at the center, so it directly tells us that our circuit is mismatched. But with the help of a circuit which consists of course, B was capacitor. And now you also know what is X. X is positive, X is the reactance, and when reactance is positive, it means this is inductor. So with the help of capacitor, which will provide 0.3 susceptance, and inductor, which will provide 1.4 reactance, this point has moved to this point. So now our circuit is matched. So what is the conclusion over here from this circuit? So what we have found is, we now know that this x has to be, uh, this is small x, and it has to be plus 1.4, small b, which was equal to plus 0.3. So this was, it means plus 0.3 mean that we have to use a capacitor over here, and we have to connect an inductor over here. So the question is, inductors are characterized by their inductance, and capacitors are characterized by their capacitance. So we know how much reactance this inductor will provide, but we don't know what is the value of that. Similarly, we know that this is the capacitor which will provide plus zero point 0.3 susceptance, but what is the value of this capacitor? So now this is some basic electrical engineering stuff. Capacitor, let's first look at B. So B की वैल्यू हमारे पास आई है जी प्लस 0.3. उसके बेस पे हमने डिसाइड फाइंड किया कि ये कैपेसिटर है. Now we know that capacitor susceptance B is equal to omega c, और B is equal to 2 pi fc. ये जो स्मॉल b हम लिख रहे हैं नॉर्मलाइज्ड है. सो अगर मैं इसको नॉर्मलाइज करना चाहता हूँ, सो स्मॉल b को हम क्या लिखेंगे? स्मॉल b is actual susceptance डिवाइडेड बाय, क्योंकि ये नॉर्मलाइज है तो उसको नॉर्मलाइज करने के लिए हमें इसको किस पे डिवाइड करना पड़ेगा, वाई नॉट पे डिवाइड करना पड़ेगा। या आप ये भी कह सकते हैं कि इसको हमें जेड नॉट के साथ मल्टीप्लाई करना पड़ेगा। So now we know the relationship of small b with the actual v. तो यहाँ पे जो हम b लिख रहे हैं इसको हम इस तरह लिखेंगे कि b इज इक्वल टू कैपिटल B इंटू जेड नॉट, और कैपिटल B हमें पता है किसके बराबर है, कैपिटल B इज इक्वल टू 2 पाई एफ। सो B इज इक्वल टू 2 पाई एफ C इंटू जेड नॉट। सो ओवर अननोन हमें क्या फाइंड करना है, C फाइंड करना है। सो C की वैल्यू क्या आ जाएगी, B डिवाइडेड बाय 2 पाई एफ जेड नॉट। ओके, B हम फाइंड कर चुके हैं 0.3। 2 पाई एफ, इफ यू रिमेंबर एफ हमने किसके लिए करना है, 500 मेगाहर्ट्ज के लिए फाइंड करना है, तो यहाँ पे आप पुट करेंगे 500 इंटू 10⁶, और जेड नॉट हमें गिवन है 100। तो इस इक्वेशन को आप जब सॉल्व करेंगे आपके पास सी की वैल्यू आ जाएगी। इसकी वैल्यू तकरीबन आती है 0.92 पिको फैरेड। तो इस तरीके से आपने बी की वैल्यू फाइंड कर ली है, ठीक है। और इस तरीके से यहाँ पे जो इंडक्टर हम यूज करेंगे जिसने हमें कितनी रिएक्टेंस प्रोवाइड करनी है 1.4, इससे हम एल की वैल्यू निकाल सकते हैं। कैसे निकाल सकते हैं ये भी आप देखिए। सो हमारे पास एक्स है प्लस 1.4, क्योंकि ये पॉजिटिव वैल्यू आई थी इसके बेस पे हमें इंडिकेशन हो गई थी कि यहाँ पे हमने इंडक्टर यूज करना। अब इंडक्टर की जो रिएक्टेंस है जिसको आप एक्स से रिप्रेजेंट करते हैं, वी नो इट इज इक्वल टू ओमेगा एल, और आप कह सकते हैं 2 पाई एफ एल। अब ये जो है ये नॉर्मलाइज्ड है, तो अगर मैं x को नॉर्मलाइज करूंगा तो इसको मैं किस पे डिवाइड करूंगा, z नॉट पे डिवाइड करूंगा। सो x नॉट डिवाइडेड बाय z नॉट से मेरे पास नॉर्मलाइज्ड x आ जाएगा। सो यहाँ पे जो x की वैल्यू है इसको इन टर्म्स ऑफ एक्चुअल x हम लिखेंगे तो हम लिखेंगे x बाय z नॉट। x की जगह हम लिखेंगे 2 पाई एफ एल डिवाइडेड बाय z नॉट। अब जो अननोन हमारे पास है वो ये वाला है, इसको हमने फाइंड करना। सो इसको आप एल के लिए रीअरेंज करें तो एल के इन टर्म्स ऑफ एल आ जाएगा एक्स जेड नॉट डिवाइडेड बाय 2 पाई एफ। एक्स की वैल्यू 1.4 है, जेड नॉट 100 ओम के बराबर है, 2 पाई एफ की वैल्यू है 500 इंटू 10⁶। तो इसको जब आप एल के लिए सॉल्व करेंगे ये आपके पास तकरीबन आता है 38.8 नैनो हेनरी। सो नाउ फाइनली आप कौन सा सर्किट शो करेंगे जो आपका फाइनल सोल्यूशन होगा। So using this particular configuration of inductor and capacitor, what will happen that यहाँ से जो अब सिग्नल आ रहा होगा, यहाँ पे ऑफ कोर्स कोई सोर्स कनेक्टेड होगा और यहाँ से एक सिग्नल आ रहा होगा। as soon as it arrive at this point, इसको ऐसे फील होगा कि इसके आगे मैच लोड लगा हुआ है, तो यहाँ पे जो रिफ्लेक्शन कोफिशिएंट होगा वो किसके बराबर होगा, 0 के बराबर होगा। क्योंकि ये जो आपने सर्किट लगाया हुआ है इसको हम कह रहे हैं एल नेटवर्क। इसने क्या किया है कि इस लोड को ट्रांसफॉर्म कर दिया है। यहाँ पे ZL है जो कि आपको क्लियरली नजर आ रहा है कि Z नॉट के बराबर नहीं है, लेकिन यहाँ पे जब इम्पिडेंस अगर हम मेजर करें इस जगह, यहाँ पे जो इम्पिडेंस होगी जिसको मैं Z इन कहूंगा वो Z नॉट के बराबर हो जाएगी। तो यहाँ पे जो इस सोर्स को ऐसे लग रहा होगा कि यहाँ पे क्या लगा हुआ है, एक ऐसा लोड लगा हुआ है जिसकी वैल्यू Z नॉट है। तो एज अ रिजल्ट इसको मैच कंडीशन, ठीक। So that is the whole purpose of using L network. Now, before we move on to the next session, यहाँ पे एक चीज मैं और क्लियर कर दूं कि जो हम, आई होप कि ये डिलीट ओके। एक चीज यहाँ पे आपने इंश्योर करनी है कि जितने भी हम नेटवर्क डिजाइन करते हैं उसका अगर आप एनालिटिकल मेथड देखें तो उसमें जो सोल्यूशन आता है उसमें दो सोल्यूशन आते हैं, क्योंकि उसमें जो इक्वेशन होती है क्वाड्रेटिक इक्वेशन होती है, और क्वाड्रेटिक इक्वेशन को जब आप सॉल्व करते हैं तो उसके दो सोल्यूशन आते हैं। तो इसका मतलब है कि जब आप इम्पीडेंस सर्किट डिजाइन कर रहे होंगे तो एट द एंड आपके पास दो चॉइसेस होंगी, दो सर्किट्स होंगे जो आपके प्रॉब्लम को सॉल्व कर सकते हैं। इस वक्त जो मैंने एल नेटवर्क आपके सामने सॉल्व किया था उससे आपके पास एक सोल्यूशन जो मैंने फाइंड किया था उसके बेस पे मेरे पास ये सर्किट आ गया था। द क्वेश्चन इज कि इसका दूसरा सोल्यूशन हम कैसे फाइंड करेंगे। स्मिथ चार्ट ग्राफिक एनालिटिकली तो आपके पास क्वाड्रेटिक इक्वेशन होगी, तो ऑफ कोर्स उसमें प्लस माइनस की वजह से दो सॉल्यूशंस आ जाएंगे। नाउ वी आर आल्सो इंटरेस्टेड कि स्मिथ चार्ट भी इट शुड आल्सो प्रोवाइड अस विद टू सॉल्यूशंस। तो पहले मैंने जो आपको अभी स्टेप बाय स्टेप प्रोसीजर बताया उसमें हमने एक सॉल्यूशन फाइंड किया। क्वेश्चन इज कि इसका सेकंड सॉल्यूशन हम कैसे फाइंड करें। तो सेकंड सोल्यूशन के लिए अगेन अगेन आई थिंक मैं इस मीटिंग को यहाँ पे ख़त्म कर देता हूँ, क्योंकि 2 मिनट्स हैं, 2 मिनट में ये कंप्लीट नहीं हो सकेगा। सो आई डोंट वांट टू बी इंटरप्टेड इन द मिडल। सो लेट्स मूव ऑन टू द नेक्स्ट मीटिंग सेशन।